Have you ever wondered how camera flashes work? It works due to a small component called capacitor. This capacitor can store a large amount of energy and release it instantly. So let's try to understand how a capacitor works. For that, we'll take two conductors. These conductors on its own doesn't have anything peculiar happening to it, right? There is no charge accumulation, there is no current, there is no potential difference, nothing is there. So what we'll try to do? We'll try to add a potential difference. And how can we add a potential difference? By connecting it to a battery. So when we connect a battery to a system, what will happen? To understand that, we'll take another system where a bulb is connected to a battery. When a bulb is connected to a battery, what happens? The potential difference that the battery creates will make the charge flow throughout the circuit. This flow of charge is what we call as electric current. And when the current flows through the bulb starts to glow. Similarly, in our case, when the potential difference is added to the system, the charge will start to flow. And that is, the electric current is established in our system. But this current can go till here only, because as soon as it reaches here, there is a gap between these two plates. So there is no path for the charges to move from this plate to this plate. So what happens? All the charges will start accumulating in one plate. And similarly, an equal amount of negative charges will get accumulated in the other plate. So this configuration is what we call as capacitor. So what is a capacitor? Capacitor has two conductors separated by a distance and having equal but opposite charges. So due to this lot of small positive charges, there will be an effective positive charge in one plate. And let's call that effective positive charge as plus Q. And similarly, due to a lot of small negative charges, there will be an effective negative charge in the second plate. And let's call that as minus Q. So as we have seen, initially when we just took two conductors, there was no charge in it, right? So the potential was also zero, charge is also zero. But when we added a potential to it, what happened? Suddenly charge starts to appear. That means the charges increases as the potential increases. So we can write this in a different way as Q is directly proportional to V. So as potential increases, charge is also increasing. And we can remove this proportionality sign. And how can we remove a proportionality sign? By adding a proportionality constant. So Q will be equal to C times V, or C is equal to Q by V. So this C, the proportionality constant, we call it as capacitance. Capacitance. And what is capacitance? So capacitance of a capacitor is the amount of charge that it can store for a given voltage. So capacitance shows the ability, or it measures the ability of a capacitor to hold the charge. So the higher the capacitance value, the more the charge the capacitor can store. Now let's look at the SI unit of the capacitance. So what is the SI unit of capacitance? From this equation itself, the SI unit of charge is coulomb, right? We know that. And what is the SI unit of voltage? It's volt. So from this, we get the SI unit of capacitance as coulomb per volt, right? But instead of writing coulomb per volt all the time, we have given it a different name, and that is farad. So SI unit of capacitance is farad. So that's all for today. Thank you and have a nice day.